Hello folks, welcome back to the channel. It's Sunday, so as usual, Sunday video. And today I thought I'd do a video on Aleo. So, in case you missed it, Aleo is a blockchain recently launched on Flipside. I mean, we recently have his data. And yeah, from what I've read in the past few days, Aleo seems to be like a blockchain with privacy baked into it. And so I'm just reading through the documentation. Just go to Aleo docs and you can find all this information. And I guess the first thing that I want to show is blocks, right? And maybe I'll make it into a series where, as I explore more things, I'll just put them into, share what I've learned so far. So right off the bat, if you expand the core schema, you can see that there are a few block related tables, right? There's like fact blocks, block solutions, and then round patches. And so I was looking through the documentation to see like what exactly are these things mean. And yeah, from what I've seen, fact blocks, which is the usual suspect you would expect in the fact blocks table, is information about the block itself. And there are two things that stand out to me. If this is able to load, one is block reward and puzzle reward. So that got me into looking into what exactly those are. And turns out in the Aleo blockchain there are things called provers, where let me see if you can find. Yeah, like this is, again, you can read this if you want, but essentially there are this people called, or group of people called provers, where they solve coinbase puzzles and then they get rewarded for solving those puzzles and then submitting the proof, I guess. Right, so that there's this group of people called provers. And I was looking also at the block explorer, in this case Aleo scan. I chose like a random block, and there is a tab called puzzle solutions, and all these are confirmed solutions, and I think these are the provers, and so they are being rewarded for submitting proofs. Another interesting thing I've noticed is that even though the block itself has no transactions, you can still submit a proof. And so I guess the puzzle isn't related to a transaction, instead it's related to some sort of block level puzzle, right? Another thing I'm noticing is that the block times are very fast. So let's say this is 241, this is 8:35 p.m. The next block is, well, I guess in the same second, 8:35, and then it changes by a few milliseconds, 7 milliseconds. So the blocks are pretty fast, and that's why I think if you look at the block scanner, there's already like 1 million plus blocks, and this thing launched in sometime in September. So yeah, pretty fast. Okay, so I was saying, in fact blocks, what stands out to me is the block puzzle, the block reward, and also the puzzle reward. Now, as I was looking through the tokenomics, and I was trying to make sense, like, where does the block reward and I guess rewards come from? So it comes from inflation. So it says here, in the first year, inflation rate is about 12%, and it decreases over time. And then there's also a chart here that shows you the initial supply and then sort of like the inflation trending towards this as the maximum supply over time. And if you read this closely, it says the Aleo network will issue Aleo tokens as rewards to provers for solving puzzles. Okay, so that's the provers part, and validators for securing the network, participating consensus. So, and then it also says the coinbase rewards for provers or validators decrease linearly over 10 years. So there's something called coinbase rewards, And I was reading through the documentation, and it's where I find this coinbase reward. So it seems like this is a variable that decreases. It is inflation, right? The blockchain issues new Aleo tokens to cover this reward, and it decreases over time. So I'm curious to see like what is this reward, like how much is it, and how much is it decreasing over time. And then there are also other stuff that I'm still not clear. Like for example, I think Aleo has staking, but I'm not sure where staking comes from. And also block rewards. It seems like the validators earn a constant block reward of 23 tokens, but from what I've seen, I'm not sure if it's 23 or like 23 with some dust. So we'll get into that in a bit. So yeah, so maybe the first thing I'll show is that this is an overview of all the blocks, and you can see that for some blocks there are no puzzles. Sorry, there are no provers submitting solutions to the puzzles, and so the puzzle reward is 0. And then even though it's 0, the validator who included this block still needs to get paid, and so they're paid a block reward of 23. But you can see here it is not a flat 23, it's like 23 point something, right? And at first I thought if this is the transaction fee, but that doesn't seem to be the case. If you look at, let's say, just this, the transaction fee is 0.05 as compared to 0.78, right? So I'm not sure what exactly this figure comes from. But another thing I'm noticing is that some blocks have the same this figure at the end, and then if I go to the earlier blocks, it actually has a higher amount. So I don't know, maybe it's a variable as well, and maybe it decreases over time, right? But anyways, yeah, so we have so I'm interested in the coinbase reward, which again is a variable that decreases over time. And puzzle reward and block reward are information that we already have in the table. So puzzle reward and block reward. There you go, right? So first thing is we have to make this into the right decimal places, because according to this, it's 23. So this should be something like 2, 4, 6, so 6 decimal places. And I'm assuming puzzle rewards needs to be adjusted to 6 decimal places as well. Yeah, let's get right to it, right? Knowing that we have this formula, we can actually use this formula to calculate the coinbase reward. So let's just do something like block ID, block timestamp, block reward, then puzzle reward. And because we want this to be adjusted to 6 decimal places, you can just do something like this, right? Where you're dividing by 10 to the power of 6. So let's call this as adjusted. And then same thing goes to puzzle rewards, 10 to the power of 6, right? Puzzle reward adjusted. Okay. Okay, and because we know the formula for Coinbase, which is puzzle reward times 3 divided by 2, that gives us Coinbase reward. So puzzle reward times 3 divided by 2 as Coinbase. So Coinbase would then be the variable that it's sometimes present if there are provers solving puzzles, and it is a variable that decreases over time. And then block reward, yeah, we don't have to do block reward because we already have the block reward. I guess we can get what is the base block reward if we want. So meaning you see how if there are no puzzles, it is 23 point something. But if there is a puzzle reward, which means there's a Coinbase reward, which means the block reward gets added. You add Coinbase reward in as well. So if you want to get the quote unquote base block reward, we can just simply take oh, I'm just realizing now that it says here 23.8. So it is zero point 0.8. It is not 23. So if you look at the tokenomics page, it says it's currently set at 23 tokens per block. But in the documentation, it says 23.8. But in the actual block explorer, it's actually like a variable. So I'm going to calculate this. So let's just call this as like the I don't know, base issuance maybe? Okay, so block reward is Coinbase plus this, which means the base issuance is this value minus all of this value. Okay, so base issuance what am I doing? Oh, sorry. Block reward. Okay, so block reward minus Coinbase times a third of Coinbase. So minus this divided by 3. And this gives us base issuance. So supposed to be 23 point, right, just be about. Alright, cool. So our base issuance, we have 23.782343 over here, and then sometimes you see it says 23.79. So that's why in the documentation it says 23.8, but you know, in reality it's not. So pretty cool that we found this. Yeah. Okay, so because each block has no Coinbase, each block has no puzzle. All blocks. It's not necessary to have a solver for each block, and so there's no puzzle reward for each block, right? So if you want to find out if you want to chart a Coinbase chart, we would have to find a way to like, what is the actual Coinbase amount, and I'm seeing that this can vary per, within blocks of, one block number apart. So maybe we do like max Coinbase per day and see where that leads us. So I'm gonna call this as like raw, and then do something like cast this as a date. So now we have day max Coinbase reward. Maybe it's median as well, just to see what we get. From raw, group by all. Friendly reminder to just use group by all instead of group by 1, 2, 3, 4, 5, 6, whatever. It just saves so much time, honestly. Okay, so median seems to be 0, and then the max. Let's see. So day and then max. Oh wow, look at that. Wow, really? Damn. So it looks like it starts off at 190.259, I guess, and then it goes down linearly, as they say. But I think if you were to measure like how much it goes down, I don't think it's a constant amount, right? Like we've seen before I did the max, I already saw like there was a block, right, one block from each other, having not the same max Coinbase reward. And so I'm also guessing this shouldn't be exactly straight, but it looks straight, right? Alright, this is nice. Alright, so how do we calculate the gradient? Right, if you want to extrapolate this to like the full year and see how much is the Coinbase reward at the end of the 1 year, the gradient would just be the difference between the next uh, right, this is y2, right, y2 minus y1 over x2 minus x1, and because x2 minus x1 is 1, so we just have to minus the next or the current value with the previous value to give us gradient. So where's my query here? Yeah, let's just call this as like max Coinbase, daily max Coinbase, and then daily Coinbase as, and then I will need a query to get the gradient, which is I'll just do like lag, so daily max Coinbase, and then the previous day's Coinbase would be just be using the lag function, so lag this over nothing to partition by, so just order by day ascending, and this is the previous daily. You can also just minus it directly, but I'll just create a new column like this. So previous daily Coinbase, and then x2 minus x1, so x2 is this, x1 is this, divided by, sorry, this is y2, y1, and then x2 is just 2, and then x1 is 1, so this should is 1. So as gradient, yeah. Alright, so we have our results, which just tells us, on a daily basis, what is the max amount of Coinbase earned. And we know that this value decreases over time, which is what we saw in that straight line graph over here, right? Oops, it's gone. And then the gradient is just what is the extent of the change, right? And as I can see, it's not constant. I mean, it wouldn't be constant given how we're calculating this, but like it's almost there, right? So I'm gonna assume a gradient of negative 0.18 because it seems like all the values are either negative 0.175 ish. There's even 1.5 here, 1.8, 1.7. I'm eyeballing it, and I'm just gonna say negative 0.18 for simpler calculation. Yeah. Oh, maybe we can do. Okay, so maybe we can do something like. Oops. Maybe we can do something like this is the current value, and then what is the projected value as another line. Yeah, let's try to do that. So what I'm trying to do is, you know how this starts from September and it ends here because this is today's value, but because we know the gradient is roughly negative 0.18, we can sort of like extrapolate this. And so what if we created another line that starts from this value over here, and then apply our negative 0.18 gradient, and then see where that leads us till September. Okay, so how to do that? We would need the dim dates table to get us dates from September 4th 2024 to September 4th 2025, and then starting value of 190 point whatever this value is, and because the gradient is fixed, so gradient fixed at negative 0.18, this just means that the next day's value would just be this minus this, right? I mean this minus this, right? The gradient is just a because the day is 1, so you just have to minus it from the starting value or minus it from the previous day's value. So I need to row number times gradient and then starting value minus whatever this is, or plus starting value, since gradient is negative, so this would be a decreasing value. Yeah, I think that's it. Okay, so let's try to do this. This seems interesting. I'm gonna comment out this first and we'll join the two together at the end, but let's just try to do this first. So dim dates table is it's a cross-chain table called dim dates. It is a table that has all the dates in the foreseeable future. So you can just do something like where day between, I can even do like this, between 2024 September and 2025 September. And I just want day honestly. So date. Alright, cool. And then maybe we do the row number here. So row number over order by day ascending. If there is no this dim dates table, you can just do the generate table sequence thingy, right? But since we do have this table, we can just utilize it like so. And yeah, this looks good. So what I'm just doing is I'm just adding a row number to each day, and then I get all the dates from September 4th this year to September 4th next year. Okay. Yeah, let's start. So with I guess starting value. I mean, I can just use here. Maybe I do something like this, and then let's try it out. It's my starting value. Plus row num times gradient, which is negative 0.18, as value. Does this work, or do I need to create another CTE? Oh, cool, this works. Okay, so what I've done essentially is I took the dates from this dim dates table to get all the dates, and then I did a row number to essentially count or give a number associated with the row. So it starts from 1, but I did a -1, and the reason for that is because I want to use the row number to multiply with the gradient to give me the difference that I need to minus with the initial number. So you see how if this is 1, my initial number would then be not the starting number. And so because I want my starting number to be this, I just make the row number to be 0, and so I need to minus 1. So this now correctly states that for the first day of September 4th, the projected value is this starting value. And then for the next day, I would just minus negative 0.18. Same goes to the next day, minus 0.18, right? And then so on and so forth. And so now we have all the values up to next year, September the 4th next year. That's cool. Yeah. So I think we are ready to chart this and combine with this. So uncomment this and call this as like actual as, and then this would be projected. So now we have select from projected left joining my actual on day, right, using day, and then I just want let's call this as an actual. Yeah, I just need day projected value and actual. Maybe call this as actual value. And let's run this, see if it runs. Object, oh, projected, not project. Cool. So we have on one side all the dates, and then the projected value, and then the actual value that is from the blockchain. And this is our projected value that we project what the coinbase reward will be after 1 year using the gradient that we estimated. So I'm guessing I need a different visualization, or can I use the same one? Projected actual. Okay, so this is because there are no values, so I need to give it a value. So I can just do something like coalesce as actual value. Actually, should I mean, the reason for this, is it because it's 0 or no values at all? It looks like the reason for this is 0, but I wonder if I can just add a I wonder if I explicitly tell it to be null, if it actually be null. So let's try that out. Well, let's just try this first, see what we get. Projected, and this would be actual. Okay, I guess it'll always be here because it's 0 anyways. Last thing to try, see if it works. If actual value is not null, actual value null. Alright, so projected actual value. Okay, so it doesn't make a difference. Looks like high charts will just default it to 0 if there are no value. So yeah, not the prettiest graph, but you can see how we have the projected line here, and then this is the actual value. If you just look at it in detail, let's just use the block table. If we look at it in detail, let's say today is October the 20th. So October 20 is 181. This is so the actual value is 182, but the projected value is 181. So we are pretty close, but there is a difference there. Okay, interesting. Yeah, so I guess another thing that we can do with this is that the projected value for next year is 124. 190. Okay, yeah, so like for example right now, the highest amount of money or Aleo tokens you can earn if you get all the puzzle rewards you own, and you know meet the criteria, is puzzle reward is coinbase times 2.2/3, right? So right now it would be, if you solve all the puzzles yourself, of course there can be multiple puzzle solvers, right? But right now you would get this amount of Aleo tokens per block if you solve it solo, right? But sorry, this is the initial 190 is the, you know, in September. But if next year September, if you were to solve it alone, you would only get is it 120? Yeah, 124. So you will only get 124 times 2 divided by 3. You only get 82 Aleo tokens, which is still a lot, to be honest, as compared to 120. And then the block reward, right now, or rather in the beginning when the block started, is 190 divided by 3 plus 23.8 is 87. And next year September it will just be 120 divided by 3 plus 23.8, 63. So not that much difference, right? 83, sorry, what was it again? 80 something compared to 63. So yeah, I think it's still pretty high. Yeah, the inflation looks still pretty high. But yeah, so I guess what I want to show is how you would do a projection compared to the actual value. And I think that is all from now for me from now, at least on Aleo blocks. This is called this as like coinbase reward projection. Next, I think I would like to do, you know, actually trying out the Aleo chain, trying out some apps, and then see how that translates to the actual transactions, which are, yeah, transactions, transitions, and then I don't know, programs, labels, right? Alright, I think that's all from me. As usual, I'll put a link for this query in the description. And yeah, I hope you learned something. And thanks for watching. See you in the next one. Bye.